Hi, this is Group 28 for CAC 535 Fall 2017, and this is a demo for our project BraiNet. This project is about using BraiNet signals for authentication, and this application uh, demonstrates its feasibility and the mobile requirements. Now, before we get started, let's make sure that we have a server running on my laptop, which will be acting as the fork server. And while that gets booted up, let me explain how this will work. So, to determine which server to use, we use a offloading algorithm which uses the network bandwidth and the server execution times to determine which server is most optimal to get the quick response. And in order to test both the servers, we have made this configurable on the screen. So let's go ahead and first get the IP address of the fork server, which is my laptop, and enter in this setting. So it's 192.168.0.229. Now let's get the bandwidth. The way get bandwidth works is it uses an API call to our server and downloads a 100 KB file. And the time needed to download that file is then used to extrapolate uh, to get the bandwidth in KB per second. Now, let's say we want to use the fork server. So we would say that fork server is thrice as fast as the remote server. And if we hit test using the uh, adaptive offloading algorithm, we decided that we want to use the fork server since it is 3 times faster and the bandwidth is decent. Now, we have a lot of files over here as well as on the server. For test purposes, let's use the first file and enter the correct username. Now, what happens in the background is that it sends the file to the server, in this case the fork server, and it passes so on the server we pass the EDF file, extract the signals, use a basic feature extraction method to get a basic feature from those signals and use a comparator to compare the two signals, the one which the phone sent and the one which is existing in the database. And eventually we determine whether we need to authenticate this user or reject the authentication. Now let's give it a try with some other username so that we have a test case for failure as well. And again, this is still using the fork server. Alright, so as expected, authentication fails. Now let's say we want to test the remote server and we want to say that the remote server is thrice as fast as the fork server. And also we want to check the current bandwidth. So there you go. The bandwidth is almost the same at this moment. And if we test, we will be selecting the remote server. Now let's use some other file and let's do a valid authentication first. Now since we are using Heroku as the remote server, it should be fairly fast. There you go. And for an incorrect test, we should get authentication failed. There you go. So that's basically the application which tests the feasibility of using EEG signals for authentication. So there's one more thing that we need to check. So to measure the performance of the battery and the power consumption for the fork server as well as the remote server, we have this check battery performance. What this does in the background is it sends 50 authentication calls to remote server as well as fork server. This time we have already chosen the remote server. So this will be for the remote server. If we click check battery performance, we should see the battery level over here. So that's how we measure the performance. All right, now that we have seen the client and the mobile application, the way it performs for authentication using EEG signals that are in the form of EDF files, let's look at some performance analytics uh, based on execution times on both the fork server and the remote server. Now, the fork server is running on the local host, which we have, and here's the performance analysis. So as you can see that we have all the red dots are the failures, and we have the execution time in seconds, and on the all the green ones are successes. Now in general, because we have to go through the entire set of 64 signals and extract features when it is a successful authentication, it has taken more. On an average it takes more time, but for failures, if we figure out early enough that it's not a match, we get the results fairly quickly. And this is basically over 120 executions, and we took equal number of positives and negatives. Now let's go to the remote server. So this is BraiNet.herokuapp.com, where we have the remote execution, and here's the same graph. uh, we have execution times which are similar in trend, where we have average times for failure is much less than the average time for success.